We finished 8 and we're at 9, and I'm gonna go ahead and do all the rest of these just in case anybody that's not here has a question that they can't vouch for themselves. So it says find the derivative of the function f of x equals 13 arc sine x minus 1. So that's 13. I didn't skip any more, did I? Right, we're on number. Okay.
Well, it says x equals R, and then that's as far as.
No, we did all of it because I remember talking about it.
I got
Yeah.
it.
Okay. So then 13 arc sine x minus 1, we're going to do 13. What is your derivative of arc sine? I have not put in that last, like I haven't changed it from a minor to a major. So just to forewarn you guys that I'm going to do that soon. So you should see your grades change. If I don't, remind me tomorrow. Okay, so I should do it today. If I don't, remind me tomorrow and I'll change it during the class. All right, so u prime, what's the derivative of x minus 1? 1 over the square root of 1 minus x minus 1 squared. On the bottom, x minus 1 squared is x squared minus 2x plus 1. And then clean that up. 1, distribute your negative, minus x squared plus 2x minus 1. What do you see happening? The ones cancel out. And then your answer is literally right there. 13 over the square root, and they just write it backwards, 2x minus x squared, because anytime that x squared is negative, they like to put it in the back. So your answer for this one should have been B. Any questions? So again, if you know your formulas, that one should have been pretty easy. All right, next one. Find the derivative of the function h of t equals 2 sine arc cosine t. 2 sine arc cosine t. So this one is not product rule. It's not, it's chain rule. Does everybody understand that? So we're going to have 2. What's the derivative of sine? Cosine of the inside times the derivative of the inside. What's the derivative of arc cosine? Over square root 1. It's the same thing as sine, except for it's negative. So our u is t. The derivative of t is -1 because it says the negative derivative. On the bottom, the square root of 1 minus t squared. What happens to cosine and arc cosine? They cancel each other out. So we're just left with 2t times -1 over the square root of 1 minus t squared. And then they just put it together. So -2t over the square root of 1 minus t squared, which is C. Any questions? Number 10. Everybody good? Sorry, y'all. All right, number 11. Find the equation of the tangent line to the graph of y equals arc sine 7x at the point 1 over 7 square root of 2. So derivative of arc sine, what did we say that was again? Our u is going to be 7x on this. So what's the derivative of 7x? Square root of 1 minus 7x squared. which is 7 over the square root of 1 minus 49x squared. To find the tangent line, we need the slope, so we plug in our x value. If you clean that up, just this bottom part, 1 squared is 1. 7 squared is 49, and the square root of 2 squared is 2. And I left it separate for a reason. What can I do? Mhm. So we have the square root of 1 minus 1/2. Or the square root of 1/2. And if you guys look, they leave it. Don't forget your 7 on top. We're going to talk about that in a minute. They leave it in square root form, so watch that real fast. So what we have now is 7 over the square root of 1/2, which is the same thing. Square root of 1 is 1, square root of 2 I can't fix. We don't divide fractions. We flip and multiply. Is everybody okay with that? And our slope should be 7 square root of 2, which eliminates those. And then the way they get the rest of it is they put it into the formula. Okay, so I'm gonna slide over. Y minus y equals m times x minus x. Our y is pi over 4. Our m was 7 square root of 2. Our x is 1 over 7 square root of 2. When you distribute that 7 square root of 2, you get 7 square root 2 of x. I have 1 on the top and 1 on the bottom, so they're going to simplify to just -1. And then we're going to add our pi over 4. So there's your formula. Your answer is C. Any questions? Any more that I need to go over? All right. Go ahead and staple it and turn it in if you have it finished. Yeah, with the test, always. Otherwise, I don't know what you missed.
I'll make some comment in there, and I wish they had little hands on it before I emailed them. He said even in the hospital, but he doesn't say,
Yeah.
like.
Yeah, I've got like 10 zeros in there.
Even at the hospital, he said.
I didn't watch it.
I didn't
do
know.
like a 60 on there. Sir.
He does. I think he's doing that on purpose.
Hey, I just want to remind y'all I'm recording. We're going to go ahead and do 4-1 notes, but you will not have homework tonight. All right, 4.1 extrema on the interval, the definition of extrema. And that's just maximums and minimums. They're nothing, it's nothing crazy. So let F be defined on the interval I containing C. F of C, so when I plug in C into the function, whatever I get. Is the minimum of F on I when F of C is less than or equal to F of X for all X and I. You're gonna write basically the same thing, but we're gonna talk about a maximum and it will be greater than or equal to. So F of C is the maximum of F on I when F of C is greater than or equal to F of X for all X and I. And you already know this. It's normal max and mins. It's nothing crazy. Okay. A function need not have a minimum or a maximum. On an interval, for instance, in the figures below, A and B, you can see the function f of x equals x squared plus 1. Has both a minimum and a maximum. On the closed interval, -1 to 2. And closed just means it has brackets. And that's this one where it's showing you, and I'll move it back, sorry. This bottom point is going to be your minimum and up here is going to be your maximum on that interval, okay? If it was all real numbers, like it didn't specify that interval, then that would definitely not be your maximum, okay? It's just your maximum because they stopped it. But does not have a max. On the open interval, -1 to 2, because it's an open point. Moreover, in C, you can see that continuity or the lack thereof can affect the existence of extrema on the interval. This suggests the theorem below, and it's actually on the next page. If f is continuous, on a closed interval a to b, then f has both a min and a max. On the interval. I gotta move my paper up. Right weird. In the figure below, the graph of f of x equals x to the third minus 3x squared. I don't even know that I put that in there. I didn't. The figure's not even in there. So in your book, you can look at it. It has a relative max at the point 0, 0. And a relative min at the point 2, -4. So there's your, hold on, sorry, I forgot to change it. I couldn't see it. There's your max at 0, 0, and your min at 2, -4. You're right, good. Just want you to be able to see it. Informally, for a continuous function, you can think of a relative max as occurring on a hill on the graph and a relative min as occurring on the valley of the graph. Again, all things you already know. Such a hill and valley can occur in two ways. When the hill or valley is smooth and rounded, the graph has a horizontal tangent line at the high point or low point. So again, what they're saying is there would be a horizontal tangent here and one here as well at your high and low point. When the hill or valley is sharp and peaked, the graph represents a function that is not differentiable at the high or low point. So the definition of relative extrema, if there is an open interval containing C on which f of C is a max, then f of C is called a relative max. Or you can say that f has a relative max at C f of C. The next one is the same exact thing, except for it's minimum. So if there is an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum of f, or you can say that f has a relative minimum at C f of C. The plural of relative maximum is relative maxima. And the plural for relative minimum is relative minima. Relative maximum and relative minimum are sometimes called local max and local min, or local maximum and local minimum. Example 1 examines the value of the derivative at each relative extremum shown in the figures below. All right. Look at the very first one. Find the value of the derivative of each relative extrema shown below. So our equation, if you can't see it, is 9 times x squared minus 3 over x to the third. I need to find the derivative. How do I do that? Quotient rule. I'm gonna make it a little bit easier and go ahead and distribute that 9 in. Okay. So 9x squared minus 27 over x to the third. We're gonna find the derivative. Derivative of the top is times the bottom. Not the derivative of the bottom, just the bottom. Now, the derivative of the bottom is 3x squared times the top, 9x squared minus 27. All over x to the third squared. Clean it up. We get 18x to the fourth. We're going to distribute. 9 times 3 is 27x to the fourth, and there's a minus. 3 times 27 is 81. X squared is already a minus, so we're going to change it to a plus. All over x to the sixth. Clean it up a little bit more. What's 18 minus 27? What kind of 9? Negative 9, x to the fourth plus 81x squared over x to the sixth. What can I take out of the top? I can take out a negative 9 and an x squared. So you guys are, everything is right. Leaves you with x squared minus 9 on the top. On the bottom, I have x to the sixth. What can I do now? So this one changes to x to the fourth. And then it says evaluate each derivative at each relative extrema shown below. So you have a relative max at 3, 2. I don't know if you guys can see that. That's 3, 2. So now we're going to do f prime of 3. So negative 9, 3 squared minus 9 over 3 to the fourth. Three squared is minus 9 is times negative 9 is. Doesn't matter what's on the bottom, it's going to be 0. The only way it would matter if it's on the bottom, if there was another 0 in the bottom and it was that indeterminate kind of crazy form. Okay, but this one is a value of 0. So what they're looking for is f prime of 3, sorry, equals 0. So find the derivative, plug in 3. Same thing that we've been doing. What is this? The same as?
It's one.
When you have to find the slope. When you have to find the slope. So we've already done this, not anything new. It's just making it at the relative extrema. So tell me about this one though. What's different about this one compared to the last one? Keep going. Why? It's you. I hear you. So it's sharp and peaked. We can't take the derivative. This is not differentiable. So how can I evaluate it if it's not differentiable? Everybody understand that one? So this one is does not exist. Again, sharp. I cannot stand. Peaked. Not differentiable. All right, what's different about the next one? It's got both, right? So guess what you're gonna do? Hey. Mhm. So our f of x is sine x. So what's our derivative? My two x's are pi over 2 and 3 pi over 2. I'm gonna start with pi over 2. Guys, you've literally put that in your calculator. So I'm gonna go ahead and tell you it's 0. Make sure you put it in radians. If for some reason when you're working with sine and cosine, you're not getting the answers that you're supposed to get, check your mode. Okay, because in pre-cal we're switching back and forth between radians and degrees. cosine of 3 pi over 2 is also going to give you 0. Any questions? All right. Note in example 1 that at each relative extremum, the derivative either is 0 or it does not exist. The x values at these special points are called critical numbers. The figure below illustrates the 2 types of critical numbers. Notice in the definition that the critical number C has to be in the domain of F, but C does not have to be in the domain of F prime. So your definition of a critical number, excuse me, I'm sorry. If F, sorry, let F be defined at C, if F prime of C equals 0, or if F is not differentiable, at C, then C is a critical number of F. So then you guys are fine flipping your paper. These 2 graphs just show you, this one is not going to be differentiable because it's a peak. This one is differentiable and it does have that horizontal tangent line. Okay. Any questions so far? Right. If F has a relative minimum or a relative maximum at x equals C, then C is a critical number of F. To find extrema on a closed interval, theorem 4.2 states that the relative extrema of a function can occur only at the critical numbers. Knowing this, you can use the following guidelines to find extrema on a closed interval. All right, to find extrema of a continuous function f on a closed interval AB, use these steps. The first thing is find the critical numbers. Of f in AB. You're going to evaluate f at each critical number in AB. You're going to evaluate f at each endpoint of AB. Sorry, those should be brackets. That's your closed interval. The least of these values is the min. The greatest is the max. All right, so here's the thing. Find the critical points, plug them in. Use the endpoints, plug them in. Whichever one gives you the lowest value, that's your minimum. Whichever one gives you the highest, your maximum. Literally that, I mean, it's not hard, okay? So the next 3 examples show how to apply these guidelines. Be sure you see that finding the critical numbers. That should say function. It's only part of the procedure. Evaluating the function at the critical numbers and the endpoints is the other part. So finding extrema on a closed interval. Find the extrema of f of x equals 3x to the fourth minus 4x cubed on the interval -1 to 2. So the first thing that you want to do is differentiate. What is your derivative? What? 12x cubed minus 12x squared. I just can't hear you. Part 2 is to find your critical numbers. The way you find your critical numbers is you set your derivative equal to 0. These have a 12x squared in common, which leaves you with the x minus 12. You set both factors equal to 0. Sorry, 1. Sorry, y'all. That's what happens when you talk and write. Set each equal to 0. Divide by 12. You still get 0. Take the square root. Remember, if it was any other number other than 0, you would have 2 answers there. So when we take the square root, there's a positive and negative. X minus 1, you're going to add your 1 over and just get a positive 1. Evaluate. But you're going to evaluate for f of x. So back to the original problem. I don't care what order you put your numbers in. I always put them in numeric order. So you have the interval -1, 2. You have 0 and 1. So I always start with -1. Then I would go to 0. Then I would go to 1. And then I would go to the 2. So remember, we evaluate your critical numbers and your endpoints. So we have 3 to the -1 to the fourth minus 4 times -1 to the third. And I'll go ahead and tell you that that gives you -5. 3 times 0 to the fourth minus 4 times 0 to the third is going to give you 0. When we plug in 1, 3 times 1 to the fourth minus 4 times 1 to the third is going to give you -1. And when you plug in 2, you get -0.24. What is your lowest? So that's your minimum. What's your highest? Your 0. And that's it. Any questions? Same 3 steps. Find your derivative, find your critical numbers, and then evaluate into the original function. First thing we're going to do is find the derivative. What do we get? Derivative of 2x. Derivative of 3x to the 2/3. And it's a minus, right? So negative 2x to the negative 1/3. Good. This is the same thing as 2 over the cube root of x. The reason I write it like this is because we want to set that equal to 0. How do I solve this? Subtract this 2. I get negative 2 equals negative 2 over the cube root of x. How do I solve this? Yeah, you can cross multiply. If you want to go ahead and put that 1 and cross multiply, that's fine. Negative 2 cube root of x equals negative 2. How do I solve? Divide by negative 2. I get the cube root of x equals positive 1. How do I get rid of cube root? Cube it. Cube it. It's okay. It's okay. As long as you know how to do it, don't matter how you say it. Everybody got it? So x equals what's 1 cube? 1. One more thing that you have to do. One more thing that you have to do. What other critical number would I have in here? Let's see if you can get it. What? Nope. Why? She said 0. Why? What are your critical numbers going to be? Where is that x? It's on the bottom. Can we have a denominator equal to 0? No, we can't, right? So you got to set that denominator also equal to 0. You may want to write that down, because that's going to cause a vertical asymptote or an incontinuity. Okay. So cube that and we still get 0. So those are your 2 critical values. So for the third part, you're going to plug into that f of x with each of your values. My 2 endpoints are -1 and 3. So my littlest one was -1. My next one was 0, +1, and +3. You plug those into f of x, you're going to get, I told you the wrong numbers on the other side. I told you the numbers for this. -5, 0, -1, and -0.24. I know. It's me. I'll tell you why it's jacked up. Hold on. I'll tell you why it's jacked up. You should have yelled at me. It should be 7, 0, -1, and 16, which makes f of 2 equals 16, your max. Sorry, y'all. And f of 1 equals -1, your min. I apologize. So when I do your notes, before I copy them for you, I try to pick up on all those mistakes that I made, I messed one up or whatever. So when I was working out those first derivatives where you have the graphs, mine are all on one page. I needed more room than that because you couldn't write. Does that make sense? So now my spacing is all jacked up. So I'm looking at the bottom. This one was at the top and your question is at the bottom. Does that make sense? So I was just looking at the bottom. What you mean? Right here. You only use your critical points, your critical numbers, and your 2 endpoints. No. Just the 2 that you found and your 2 endpoints. Now, there could be more than 2 critical values, okay? So there might only be 1 critical value, there might be 4. Who knows? You just gotta find all those. So this one, we had 2 because of the denominator, so you gotta watch that. All right, look at your next one, find the extrema of this one. This is our last example, and like I said, we're not gonna do any homework, so we'll look at maybe some 37 if you need it, but I'm good with nothing. Find the extrema of 2 sine x minus cosine 2x on the interval 0 to 2 pi. All right, so the first thing that you want to do is find your derivative. What's your derivative? Okay, so we're going to do a negative sine 2x, and then we got to multiply by 2. So it's going to be a positive 2 sine 2x. Again, if you don't get that, we would have a negative sine 2x times 2. So the negative over the negative, or negative times the negative makes a positive, and I just move the 2 to the front. Everybody okay with that? All right. Critical values. Set them equal to 0. Now this one you're going to struggle with a little bit. First of all, I can factor. What can I take out? Cosine x plus sine 2x. This is reducible. Check your book and see if you see anything that looks like that. Check your book cover, see if you see anything like that.
What if something like that's on the test, not just?
You're gonna have to we're gonna study all of those formulas.
Okay. So we're gonna do it just like we done the last, when we do quizzes.
These honestly, you should already know from pre-cal. I don't expect you to know them, so understand that. But by the end of this course, you should know them. So we've done derivatives. We need to go back. We'll eventually do integrals. So that whole front page, front cover, you're gonna have to memorize. And the whole back cover, you should already have from pre-cal.
So we don't have it.
But we're gonna get it. But y'all just gotta bear with me. All right, do you see this? Do you see this anywhere? It's obviously not gonna be in the derivatives. It's on the back part. Look for the double angle formulas. What is it? What does it change into? So here's what it turns into. Cosine x plus this 2 sine 2x, sorry, I'm tripling over all words. Sine 2x turns into 2 sine x cosine x. And I just want you to know where I got that from. So that's a double angle formula. All right. Now what that helps us do is take out a cosine So you have 2 cosine x and 1 plus 2 sine x equals 0. You're going to set each factor. Equal to 0. We're going to divide by 2 on this cosine. And we're going to find everywhere between 0 and 2 pi that cosine x equals 0. So I'm going to change my window. So I changed my window 0 to 2 pi because that's what our interval is. Everybody understand that? And then I went by pi over 2 again. If it was weird, I can change it. Remember, our unit circle goes pi over 4 or pi over 6, right? So in a minute, I might change it again. So we can see our zeros, and I can see that my marks are what? I changed my marks are what I tell you my interval was, pi over 2. So this one is pi over 2. What's the other one? Mm-mm. Mm-mm. This is 1/2, 3 pi over 2. 1/2, 1, 1.5, or 3 pi over 2. There you go. So we already have 2 critical numbers. We're going to have more because we have the other side. We're going to do subtract 1 and divide by 2. So here's what I did for this one. I put it in my calculator, sine x. And then in y2, I put in -1/2. Now you could have done 1 plus 2 sine x. It would have been fine. And then we're looking for where it crosses. Okay. But this one I didn't. I'm still at pi over 2. And you see how it crosses not quite in the middle. Does everybody see that intersection's not quite in the middle? So what I went back and did was I changed my window, my scale to pi over 4 to see if that would help. So it just puts more little marks in there. Don't look at the 0, look at the red line in just a minute. And it still crosses in between 2 of those. So then I went back and y'all, I do it differently because I know my trig functions and my circle and stuff like that. Y'all don't. So this is how you would do it. I changed it to pi over 6. Again, our unit circle is based on pi over 6, pi over 3, pi over 4, pi over 2. Those marks will get you where you need to go. So when I graphed, I see that it crosses at this one and this one. Count them. 1, 2, 3, 4, 5, 6, 7 pi over 6. Eight, 9, 10, 11 pi over 6. If you could reduce those, you want to reduce them, it doesn't matter. So there are your critical numbers. Okay. Again, if you went back, 1 plus 2 sine x to right here equals 0. That would be perfectly fine. There's your 7 pi over 6 and your 11 pi over 6. So you didn't have to get it all summed up or whatever. Okay. You can also use the unit circle on this. Wherever your y coordinate is -1/2 is where you have critical numbers. Right. Part 3, you're going to use that f of x and your critical numbers. So 0, pi over 2, doesn't matter what order you put them in. Again, I told you 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. So this one had a lot. For f of 0, you get -1. For pi over 2, you get 3. 7 pi over 6, you get -3/2. And again, this just put it in your calculator, straight type in. 3 pi over 2 is -1, -3/2, and -1. What do you think? So you have mins at -3/2. And then max is at 3. And that's all you guys have to do. We will do our 4-1 homework in class tomorrow. Very good. All right. So you get a little bit of a break. I'm gonna stop sharing, stop recording.